My name is Shahat Nyamariza. I am a teacher by profession at Mackay University. I teach mathematics and physics, and I teach schools like Muhabura Shine, Kisoro and most of other online classes that want to encounter mathematics and understand mathematics and physics in reality. I have brought a system of uploading my video lectures on YouTube and also on TikTok and all other online channels for all my students who want to see and be encouraged to understand mathematics. Most especially for my students, I've brought them as a category of them understanding deeply what mathematics mean and physics mean in the daily nature as the way new curriculum is reading us too. And another thing that I have encountered, I want my students always, whenever they don't get something in class, to go back to the YouTube channel. They click on the link and they watch every video, every lecture that they have not understood fully in class. And that's why I've brought that system for all my students to understand realities about math, and knowing that math is not a complex subject. Even physics may be simple to a person who had a sharp mind and wants to understand. And in most cases, this process has worked and has worked before, where I can, during the holidays, I've been teaching via online, I've been teaching on YouTube, I've been teaching on Zoom, and people have been following and doing it in accordance to the way how I believe them. So I thank my partners like the school experience and other people I'm partnering with in this journey of uploading my videos on YouTube and also on TikTok and all other online channels, so that the experience of math and physics can reach on everyone. I'll be broadcasting not only A-level classes, but also O-level classes shall be uploaded in soon after, and everyone shall be able to read and also can shall be able to see the pictures fully and get the area of mathematics very well, where he needs to understand. Even after 10 years, after 20 years, these videos shall be still there. A student who may have studied my class, in my class, may go back and see the videos and see the way how we used to be in class for remembrance. So I thank you so much, and everyone who is watching, please keep updated. And if you're interested in the channels, you can get the links from us, and then you'll be following us every other day. Otherwise, I thank you for your attention to me. I remain Shahat Nyamariza, a science teacher, physics, mathematics at Muhabura Shine, at Kisoro, and all other schools that would want to link us. No problem, they can join. Thank you. At the bus park, okay? Yes. 60% of the buses are of what? Tesla coaches, okay? Yes. 25% are, and the rest are what? YY coaches, okay? Of the Tesla coaches, 50% have televisions, okay? Yes. While Kakise and YY buses only have 5% and 1% having televisions, what? Respectively. Now, when you read that, already that is an application of what? Of biotheory, okay? Yes. Meaning that we have Tesla coaches, we have Kakise and YY buses. Yes. So meaning in our response, we need to know which event is intersecting on both. This is an application of biotheory. So we shall say our response response. We are responding to the what? What are we going to use? Which events? Huh? We can use A, okay, B, and C. B events. Okay? Okay? That the buses, okay, the buses used are what? Teso, okay, Kakise, and YY, and YY respectively. We are going also to know which event is intersecting all of them. Which event is that? Having what? Television. Them having? Television. So we shall also say let. Okay? Which one can we use? T. Be an event that the bus used has a what? A television. We know the characteristics. We have the application of Bayes theorem. We understand the characteristic of a Bayes theorem. We have three categories of events, and these are the events which we have. Okay? Now we have we have this. I have event A, I have event B, and I have event what? C. I have the intersecting part here, and the intersecting part is event T. Okay? I have A intersection T here. Are we together? Yes. B intersection what? And C intersection. Now I get the probabilities. So from the question, what is the probability of A? Is the same as 60%. And in simple terms, what is 60%? This one is 0.06. Probability of B becomes what? 25%. And this one becomes 0.25. And what is probability of C? Okay? They are saying the rest. Okay? So you get 100%. Okay? Then minus what? The addition of 2 percentages. 60% plus 25. And this one becomes what? 100% minus 60 plus 65 plus 25 becomes what? And this one becomes what? 15%. And this one, when it is expressed in decimal points, it becomes 0.15. When we are interpreting 50% from Tesla coaches have television. So it means probability that a bus has a television, given that it is what? It is a Tesla coach percent. 50%, which is 0.5. Probability that it owns a television, given that it is from what? Kakise, becomes what? 5. And this one is 0.0 what? And probability that it owns a television, given that it is from YY, becomes what? And this one becomes 0.0. So what are they? The probability that the bus has a television. Probability of T. Are we together? Yeah. Implying that to get probability of T, we get this one plus this one plus this one. Are we together? Yes. So meaning that we get probability of what? Of A intersection T, which is this one, plus probability of B intersection T, which is this one, plus probability of C intersection what? But using the conditional probability, they all said it is an extension of conditional probability. We say that on A out of probability of what? Out of probability of A. I said that this one is the same as probability of A intersection T. It is the same as that. Whether you begin with A or T or the same. So meaning that here, it means that this probability will be the same as probability of T given A times probability of A. Are we together? Yes. plus probability of T given B times probability of B. Are we together? Yes. Plus probability of T given C times probability of what? Famous. We already have this one. Probability of T given A is 0.5 times, okay? 0.6 plus 0. What? What about this one? Becomes what? 0. Times 0.25 plus 0.01 times 1.5. So meaning that my probability of T using the calculator, what do we obtain? Using the calculator, get for me this one. Okay?
0.314.
Just raise your arm and get you saying 0.3 plus 0.012 plus, all of you are doing 1. Like that.
314.
0.314. And say, now therefore, probability that, the probability that, okay, the bus has a television is 0.314. As simple as that. Very happy. You have the phone is. Are you sure? You have the phone here? Yes. Now, I also talked about that Bayes' theorem is an extension. We talked about when we are using the Bayes' theorem, we are using the extension of the probability is just given. Now, when you talk about part B, find also the probability that Kakise bus is selected, given that it has a television. I said given. The word given is a key. Given that is a key. Mapera, are you there? Given is a key. Given that. So now, meaning given that it is what comes down. So given that it has a television, so T must be down. T must be where? Down. So meaning that our part B, they are asking probability that it is from Kakise. Kakise is B. Kakise is what? Is B, given that it has a television T. What is that? This is probability of B intersection T out of probability of T. And this one will be the same as B intersection T is here. Don't waste time. It is the same as 0. It is like probability of, when you look at this already, T given B times probability of B out of probability of T. And this one will be the same as T given B 0.05 times 0.25 divided by probability of T is 0.314. Get for me that answer. What is that answer?
0.398.
98. Very good. Talking about. Okay, now from 1 to 2.4 x squared plus sine x dx using five strips. You need to understand this is trapezium rule, okay? Yes. And we say that in trapezium rule there are two things that you need to know. Number one, you need to know the difference between ordinates. Then we have what they call strips. They are the same as subintervals. Okay? Also same as subdivisions. Are you getting that? Now, when we talk about ordinates, for ordinates, these are spaces in between the strips. And when we are getting their number, we say it is number of subintervals minus what? So that's how we get the number of subintervals when we are given ordinates. Are we together? Now, this part here of trapezium is is looking at the area, and the area under this function. By trapezium rule, we say that if you're given a function, and this function is f of x, this function is f of x, y is equal to f of x, and this is x. This is the function. Now, we say that to get area under this function, from A up to B, the area under the function, we divide this interval into small subintervals. We divide it into small subintervals, and these small subintervals are joined together. And when they are joined together, they are joined to form what they call a trapezia. They are joined to form a trapezia, small trapezias. And these trapezias, as you connect one to another, there is an error that is made, Now, when you add the area of all trapezias, that gives you the area under the given function f of x. Okay? Now, in this case, for you to minimize this error that is being made, you add the number of subintervals. In other words, the subinterval becomes closer to each other, like this one. When you come and put a subinterval here, you connect this one to here, now a small error will be made. When you come and put another subinterval here, and you connect here, now a small error will be made. A subinterval here, you connect here, a small error will be made. So to eliminate the error is by adding the number of subintervals. Even when subintervals are close to each other, the error is getting eliminated. The error is getting minimized. Are we getting that? So now when you talk about this question, it means we are talking about how do we get the area under that function. Okay? H, okay, is the same as it is always got by b minus a out of the number of subintervals. Okay? Yes. And b is called the what? Upper limit of the integral. Okay? A is called the what? Lower limit. And n is the number of what? Number of strips or subintervals. Are we together? So meaning that in this case, our n is equal to what? Subintervals or strips are what? 5. So our h becomes b. What is b? B is the upper limit, which is 2.4 minus 1 out of, and this one becomes what?
0.288.
0.288. After dividing, draw a table, and then we write the value of x squared plus sine x. Of course, it is after integration, after the integral. You get the value. If you want, you can put the integration sign there, or you can just leave it like that. There is no problem, even if you put the part there. If you put the integral part, there is no problem, even if you can say integral from that part, the x. So what is the part? We are going to begin from where? So when you get 1 plus 0.28, you get what? 1.28. Plus 0.28 becomes what? 1.56. Plus 0.28? 1.84. plus 0.28, 2.1, plus 0.28, 2.4. And then we have another line here, and we are talking about the summation. This is the summation. Summation. Yeah. Remember, we are already in trigonometrical ratios. When they say trigonometrical ratios, when we are dealing with trigonometric ratios, the calculator should be put in radians. That's what we talked about. So meaning that you will put this 1. What do you get? 1 point. We just increase to more than 3. 1.8415. And then put 2.4. Others should be doing this and that. 6.4. Good. This one? 3.4335. This one 1.84.
4.3496.
And then what about 2.12?
5.3473.
5.3473. Now summation means you add. Remember in the pi theorem, or rather in the trapezium rule, we said that when you are getting trapezium rule, you get f0 plus fn. In other words, you get y0 plus yn. The value of the y value for the first strip and the last one, you add them together. So what do you get when you add this? 8.277. Huh?
Yes.
Exactly this one.
Yes.
0. I want to protect my 3 significant figures. What about here?
15.7268.
7268. Good. Now you say my integral from 1 to 2.4. X plus sin x dx is approximately equal to, okay, a half times h. H is 0.28 into 8.2770. Are we together? Then plus 2 into 15.7268. It is approximate value. So 28, not 2. What's the answer? This becomes 0.14 into 8.2770 plus 2 into 15.7268. And this one becomes what? Our A approximately equal to what? 5.562. They want 3 significant figures. Are these 3 significant figures? Make 3 significant figures, okay? A is approximately equal to 5.56. And they say 3 significant figures. He does not believe much whether it rises in this what? In this range. So how are we going to tell him? They said, as a mathematical student, show him that it holds, leaving your answer to 3 significant figures. So how are we going to tell him? How are we going to tell him? Therefore, since A is approximately equal to 5.56 and it rises between 5.56 rises between 5.4, okay, up to 5.7, then it does what? It holds. You can put them, but not so much. Are you getting me? You can put square unit, but not so much. Now, this one is the trapezium rule. And you said trapezium rule when you are using trapezium rule. Expression itself. That's why when they ask you the error, this one is called the approximate value, and the exact value is got by integration. When you integrate this one, that's when you get the exact value. I don't know whether you have studied in paper 1 how to integrate sin x. Huh? Have you studied? Huh? When you integrate sin x, what do you get? Huh? You have studied differentiation. So I wanted to do the exact value, and you get the percentage error. But still, you can still do using the. There are sometimes where we use by parts, but this one is not by parts. It's just Leo. You just integrate Leo because this is x squared and this is sin x. But the exact value should be also almost near this answer. Almost near this answer. Though this one is an approximate value, and the approximate value we get it by Trapezium rule. By using Trapezium rule, that's when we get the approximate value. Then the exact value can be got by integration. Okay, can be got by integration. Value will be the same as integral from 1 to 2.4 x squared plus sin x dx, which will be the same as, okay, integrate x squared, you get x cubed out of 3, okay, plus when you integrate sin x, okay, all together, you get negative cos x, and then you say ranging from 1 to 2.4, and then you substitute the limits. You get 2.4 cubed out of 3 minus cos 2.4, okay? Then minus 1 cubed out of 3 minus cos 1. And then you get the answer. Don't know who's good. I'm sure that is 0. So the answer which it will give us will be almost near this answer. Will be almost near this answer. Can you give me the value? Can you Moses give me the value? 5.55. 5.55. Okay? Now, error, absolute error. How did we say absolute error is obtained? It is the magnitude of exact value minus what? Approximated value. Approximated value. So which is the same as magnitude of 5.55 minus approximated value is 5.56. And this one will be the same as 0.0 what? 1. That is the absolute error. How do we get the percentage error? Percentage error. How do we get the percentage error? I want to get, it should be a positive. And is equal to absolute error. Absolute error out of exact what? Out of exact value times 100%. And this one will be the same as absolute error 0.01 divided by exact value 5.55 times 100%. And this one will be the same as 0.1 what? 18%. And now they may ask you, how do you reduce on this error? I say that to reduce on the error, okay, we can minimize the error by number 1, by increasing the number of what, Jennifer? The number of what? The number of what? The number of sub-intervals, ordinates, or strips, or subdivisions. And another one we said what? By recording to more than the required number of what? Number of decimal places. That's how the question comes. But this is an act of paper 1. This one. You need to know how to integrate those things. When you integrate cos x, you get negative. Sin x, negative cos x. When you integrate cos, you get sine, positive sine. you need to know. So I think that is this is our end of the lesson. We shall meet next time. Okay? We shall meet next time, and we can now go for lunch if you are done. And then as we get the other part of your class, talk about how is this method of capturing how we are teaching on Zoom, right? And on YouTube, how it is going to help us as students and how it is going to help you learn. Okay?
Greetings to everyone, and I take this honor to welcome you to this lesson. I'm called Akijuka Robinson Davis, a class counselor, Senior 6 Sciences. I encourage you to follow us and enjoy the experience of mathematics as we make it the simplest of all. Otherwise, I thank our teacher for this lesson and for the organization for us to catch up. And I think this one will help most of us, especially those people who have not made it to the lesson. And it shall also help us to capture and remember what's taking place even when we have not managed to encounter it from class. Otherwise, thank you for your attendance and thank you for the participation. That's it all. A blessed day.
Greetings to everyone. My name is Nyongru Pretty, Senior 6. It has been an enjoyable lesson. We say thanks to our teacher for the good explanation and everything. And we thank him for this unique opportunity, because on this we get a chance. If you are not got something you can go, there is a chance of going for a redo. So we are so grateful, and we urge everyone out there to enjoy this opportunity. Don't miss it out, because it is not for all. Come and enjoy the best of the mathematics lessons here. Wish you all the best.
School Experience Magazine.
Experience Magazine.
School 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 Experience Magazine.